as we get older, we see things that are not possible. And when you're young, you just see that all things are possible. And I want to get my mind back in that space where I don't see the hindrances, I don't see the challenges, I just see the possibility in everything. And that's what I love about these ideas, and that's what I love about this particular event. I think it's really, we can learn from you, if not just your actual innovations, your actual ideas, but just the approach to them, which is really, I think, what we can learn lessons from the youth, or maybe remember our how we used to think back in the day. I know I sound like a real grandma, but hey, it is what it is. So officially, welcome everybody to our Greenovate Award winners, our 2021 Greenovate Award winners. They'll be sharing their winning submissions with you. Special thank you to Growthpoint. Greenovate is a Growthpoint initiative, and I don't know how many years we've done it, but it's really part of my highlights in the year. So the topics, and this is where I really had to practice some of the words, but they range from manufacturing tiles from copper mine tailings using geopolymerization, industrial LED fixtures, mechanical and durability properties of concrete, containing recycled plastics, plastic waste, resin and PET, as a sand replacement, a life cycle cost analysis of developing high-rise, sustainable, innovative, affordable housing in South Africa, experimental process for introducing chicken manures and additive important cement to decrease pollution and increase thermal insulation, as well as other properties of the concrete mix, and investigating the adoption of green building features, initiatives, and technology in commercial buildings. So that's a mouthful, but that's all the ideas we're going to bombard you with, and we're going to share with you. It's great. So as I said, the Greenovate Awards are brought to you by Growthpoint Properties and the Green Building Council. Every year, the competition targets students in the honours year, which is the final year of study, from the property construction and quantity surveying departments, as well as the civil, mechanical, electrical, and electronic engineering departments. So to our panel, thank you for joining us today. We are looking forward to your presentations and hopefully lots and lots of discussions afterwards. So please, audience, get your questions ready. Let's have a real great discussion at the end of our session. And please leave your comments, questions in the chat option that's provided. And at the end of all the presentations, we will be asking your questions. So first of all, I'd like to welcome Graham Cruikshanks. He's the Head of Sustainability and Utilities at Growthpoint Properties, and he will share an update with us on the Greenovate 2022 processes and submissions. Welcome, Graham. Thank you again for being with us, and I'm going to hand over to you.
Thank you, Lisa. One of my responsibilities today was to introduce Greenovate, but I see Lisa has just done a superb job of doing that. And thanks, Lisa. I completely echo your sentiments around the level of innovation and passion and raw commitment that we see, not just this year, but every year in these submissions, or last year, because we've got last year's panelists with us today. It really is inspirational, guys, and I completely agree with Lisa's sort of summary of how the thinking patterns can become a bit jaded as more and more barriers and hurdles get put up in the so-called real world. I think it's time to turn it on its head more and more, and to introduce the level of innovation that we see at the likes of the Greenovate Awards. As Lisa's already said, the Greenovate Awards are a partnership between Green Building Council and Growthpoint, actually conceived in 2015, so we're in our 8th year, and it feels like each year the level of submissions, the intensity of the competition just gets ratcheted up. I think we had a bit of a difficult time during COVID. most of the universities had a very disrupted academic year, but we're back on track, and we're planning some interesting new things for Greenovate. Anya, could you move to the next slide, please? Thank you. As you all know, the two streams that have typically or traditionally been offered through the Greenovate competition have focused on a property section and an engineering section. And what we've historically seen is that the property section, not all, but generally, has focused on the value proposition that green buildings can make to the built environment, and quite a lot also on cost analysis. Whereas the engineering stream has focused more on technical innovations related to green buildings. Having said that, one of the interesting trends that we've seen in recent years is some overlap between the two, particularly as the students studying in the property environment, I think, encroach into the technical space, showing interest and research there. Some of the topics that Lisa mentioned just now are indicative of that. One of the exciting new developments within the Greenovate competition is our aspirations to introduce a new category focused on prop tech. And we feel that, along with GBCSA, that prop tech, although a popular buzzword in the property industry in South Africa, is probably at a similar stage of development to where green buildings were in 2015. There's a growing awareness around the potential role for prop tech in the property industry. The solutions proposed are quite often appropriate for highly developed markets in Europe and North America, and not necessarily closely aligned to the environments that we find in emerging markets like we have on the African continent, South America, Southeast Asia, and so on. So we see a real opportunity to try and find solutions out there in the marketplace and in the research space appropriate for the way that we design, develop, operate our buildings. And so what we're hoping to do is to follow the same format as Greenovate has followed traditionally, which is to partner with universities, but to extend that to startup businesses where we would like to engage with perhaps innovation hubs at universities that have them in the R&D space around prop tech, recognizing that it's a quite a financially intensive industry, and that some of the research going on in the postgraduate space up to PhD level is intensely focused on these types of solutions, and that there are a number of small enterprises trying to develop appropriate solutions. So we haven't figured out the finer details, but that's one of the exciting new developments within Greenovate that I wanted to mention for 2022. Anya, could you move to the next slide, please? And just to recap, we have loads of information at the Greenovate competition website. Please, any of the attendees on today's meeting who are interested in finding out more about it, there are contact details there. There are details on the way the competition works, and very importantly, the prize money, which I chose to highlight today, creates a hot competition amongst the entrants, and the recipients, I'm sure, will agree with me on that. So please do go and investigate further if you'd like to find out more about it. We're delighted at Growthpoint with the progress of the Greenovate competition to date. It really has entered its own space. It has its own identity, and it has its own role in industry. And we're thrilled with the progress that we've made with Green Building Council to date and the universities. I think it's time for the students to talk about the participants to talk about their submissions. I've talked enough. So thanks very much, everyone. Hope you enjoy the presentations.
Thanks, Graham. So let's go to the first. So the first presentation is the well, it's the top 3 winners from the engineering category. We'll start with the third place winner, which is Nina Serber. She's from Stellenbosch University, and she'll present on the topic of mechanical and durability properties of concrete containing recycled plastic waste, resin 8 and PET as a sand replacement. Nina completed her honours degree in civil engineering in Stellenbosch University in December 2021. She's now working part-time for a structural engineering company called Frame in Cape Town, while working part-time at a dive centre in Simonstown. Her passions are influenced strongly by the natural environment, as she loves to be outdoors and in nature. Her two main hobbies are gardening and scuba diving, and she's been scuba diving since she was 13, and I'm sure that's where her love of nature really started. So Nina, I'm going to hand over to you.
Good morning, everyone. Today I'll be presenting my thesis on the mechanical and durability properties of concrete, which incorporates recycled plastic waste as a partial replacement for sand. Next slide, please. The world is facing an environmental crisis of an extreme magnitude. As a result of the exponential growth of our population, the rate at which plastic is being produced is continuously increasing. It has been found that more than half of the plastic waste existing on this planet today has been produced in the last 15 years alone, with this amount to be expected to double by 2050. Approximately 300 million tons of plastic is produced every year. 72% of this plastic waste ends up in our landfills and ecosystems, with 14 being recycled and 14 being incinerated. Incineration of plastic is by no means sustainable, as more than 150 million tons of annual carbon emissions arise from this alone. Another environmental issue which requires serious attention is the depletion of natural river sand as a result of the ever-increasing demand of concrete, as shown on the next slide. Around 30% of concrete comprises of natural sand. Some of the major consequences stemming from this is the overexploitation is the increase of the depth of our riverbeds, the lowering of the water table, and the intrusion of salinity into rivers. Not only does the use of sand and concrete affect the rivers themselves, but the transportation and mining of sand is also detrimental to the environment. A new and emerging sustainable solution, which responds to both of these issues, is the use of plastic waste as a partial replacement for sand and concrete. Two different types of recycled plastic waste was used in this study, resin 8 and peat, as shown on the next slide. Resin 8 is an innovative plastic aggregate which incorporates all the different types of plastic. Peat is the most common type of plastic, and research has shown that peat is the most suitable type of plastic when used as a partial replacement for sand and concrete. It is for these reasons that resin 8 and peat form the basis of the study. Next slide, please. Through the analysis of various articles, it is evident that the type of plastic, particle size, and replacement content influence the performance of concrete. At high plastic replacement content, it is found that there was a drastic decrease in the mechanical and durability properties of concrete. It is for this reason that resin 8 and peat were tested at small replacement contents of 5, 10, and 15% of sand by volume. The particle size and size distribution of the different plastics was also carefully considered, as it is important to match the grading of plastic to that of sand. The grading and surface morphology of the recycled plastics are shown on the next slide. As seen on the grading curve, peat achieved a grading very close to that of natural sand, which is very desirable. With regard to the surface morphology, resin 8 is seen to be a more heterogeneous material, while peat is to be a more homogeneous material. Next slide, please. A number of different tests were performed to determine the workability, mechanical, and durability properties of the different concrete mixes. For each test that was performed, the concrete that contained the recycled plastic waste was tested against a reference mix, which contained no plastic. Some very interesting and exciting results were obtained. The mechanical properties of the concrete mixes was determined by the compressive strength test, splitting tensile test, and static elastic modulus test. Looking at the compressive strength results on the next slide, it is seen when compared to the reference mix, peat up to a replacement content of 10% increased the compressive strength of the mix. Importantly, all mixes were above the threshold for structural concrete in terms of compressive strength. This has the potential to save a huge amount of plastic, as both resin 8 and peat can be incorporated in concrete up to a replacement content of 15% and be used for all infrastructure. Next slide, please. In terms of the splitting tensile strength test, incorporating peat at all replacement content exhibited a stronger splitting tensile strength than resin 8 at a replacement content of only 5%. It was found that when the plastic content increased, a more ductile failure occurred, which is desirable. The elastic modulus results are shown on the next slide, and it was found that there was an increase in the elastic modulus of the concrete when incorporating resin 8 and peat up to a replacement content of 10%. Next slide, please. The durability properties of the concrete mixes was determined by the oxygen permeability index test and effect of elevated temperature test. The OPI test gives a measure of the the resistance of the concrete to ingress of gases, liquids, and ions. Peat was found to increase the OPI at a replacement content of 5%. The scanning electron microscopy analysis was performed to determine the surface morphology of the mixes, the interfacial transition zone, and the effect of elevated temperatures. Shown on the screen is an indication of the air void content in the different mixes, which in return affected the strength of the concrete mixes. Next slide, please. In summary, it is clear that both resin 8 and peat are suitable as partial replacements for sand and concrete. When looking at the overall performance of the concrete mixes, the optimum replacement content of resin 8 was found to be 5%, while the optimum replacement content for peat was found to be 10%. There is 10 billion tons of concrete produced every year. Incorporating plastic waste at a replacement content of 10% of sand by volume has the potential to divert 6.1% of the total amount of plastic waste produced every year for sustainable use in concrete. It is also important to reiterate that both resin 8 and peat can still be used at a replacement content of 15% for structural concrete, meaning there is the potential to even divert more plastic waste from our landfill sites and ecosystems. The concrete which incorporates recycled plastic waste can also be crushed and reused at the end of its lifespan, meaning this recycling process is fully circular. This sustainable solution can thus be a huge step in combating the plastic waste crisis. Next slide, please. In South Africa's socio-economic context, there is the potential to create thousands of job opportunities, while the concrete that incorporates the plastic waste can be used to build fundamental infrastructure, such as homes, hospitals, schools, and roads. In responding to the plastic waste crisis we are currently facing, it is critical that any and all sustainable solutions are implemented with an immediate effect. If we do not act now, the ramifications will exceed the boundaries of what human intervention can achieve. Thank you.
Thank you, Nina. Sure. That is very, very, very relevant and really close to our hearts on getting rid of a lot of the plastic waste. Okay, we'll go on to the second place winner, who was Andrea Fiorita from the Northwest University, and he will present on the topic of industrial LED fixture. Andrea completed his bachelor's degree in computer and electronic engineers at Northwest University in 2021. He's now busy with his master's degree at NWU. He loves the outdoors and gets on his mountain bike whenever he can. Hiking trips are also his perfect escape and a great way to behold the beauty of God's creation. And again, you can see the love of nature and the love of earth coming through. So, Andrea, over to you.
Cool. Hi, everyone. I'm Andrea Fiorita, and I will be presenting the industrial LED fixture. Next. So, did you know that ShopRite has a massive warehouse with a size of 123,000 square meters? So, by doing a few calculations, you can calculate the energy usage of such a large factory. Next. So, from literature, you can see that such a large space uses almost 22.6 kilowatt hours per square meter annually, just on lighting energy costs. And with an electricity cost of 140 per kilowatt hour, you can calculate the amount. Next slide. So this all equates to almost 4 million rand annually just on lighting energy costs. So how can you save on energy? Next. So you can implement a smart lighting solution, which can save you up to 45% on energy costs. And by taking the previous example into account, can save almost 2 million rand annually just on lighting energy costs. Next. So what is the current state of lighting in industrial settings? Well, firstly, there are thousands of lights, and each light uses a significant amount of energy. Then there's also inefficient lighting, such as glare and faded lights, which would decrease the productivity of employees. There's also a high maintenance cost associated with the current lighting schemes. And there's also, in such large spaces, places that are lit up but not even being utilized. Next. So how can the problem be defined? Well, firstly, you'll need to measure certain environmental variables. Then you'll use that variables to regulate the lighting in such a space. You can also store and display the readings so that the operator can easily assess the lighting scenario. Next. So what may be the possible benefits of the solution? Well, mainly there'll be a significant decrease in energy usage, which should save on electricity bills. Then there's also an increase in employee productivity because the lighting is more user-centric. It also enables an operator to easily control the lighting in any environment. And lastly, it also enables predictive maintenance to save on the significant costs associated with corrective maintenance actions. Next. So what would be the solution? Next slide. Well, the solution uses 3 techniques to save on energy. First, there's occupancy sensing, then daylight harvesting and remote monitoring. This will be discussed in the next slide. So as you all may know, occupancy sensing is when a space is occupied, the lights are on. When a space is not occupied, the lights are off, meaning a significant amount of energy is being saved. Next. Then there's also daylight harvesting. Daylight harvesting means that you utilize the incoming light from windows or a skylight to adjust the lighting in a certain space. So if there's a significant amount of light that comes in from windows, you don't have to use that much power on the lights. Next. There's also remote monitoring. So this will enable an operator to easily control the lighting scenario in such a factory setting. You can also view system parameters from a remote location and adjust the parameters from any global position. Next. Okay, so what is the system architecture? Well, it consists of a node, an LED controller, and a user interface. The node senses motion and ambient light. It sends these readings wirelessly to an LED controller. The controller will use these readings to dim the LEDs, and it will also log the data. It forwards the readings to a user interface. The user interface allows you to change system parameters and monitor the current lighting scenario. Next. So with a focus on the sensory node, it has a range of 7 square meters and would typically be mounted on a workbench or wall. The motion sensor has a 360-degree detection range, and the communication interface also has a 10-meter range. Next. Then there's the LED controller. The controller its main function is to dim the LEDs, and it would typically be placed on the mounting structure close to the lights. It communicates the readings to the user interface. Next. So the user interface is a web-hosted user interface where you can monitor certain system parameters such as the ambient light and the current energy usage. You can also adjust certain system parameters such as the LED brightness. Next. So yeah, to conclude, the LED fixture is a feasible option for any company looking to save on electricity bills. This is made possible by means of occupancy sensing, daylight harvesting, and remote monitoring. Next. Thank you, everyone. Any questions can be directed to that email.
Thank you, Andrea, for your, excuse the pun, enlightening presentation. So let's go on to the winner of this section, was Karabo Mokole. Have I said it right, Karabo? He's the winner of the engineering category, as I said. He's from the University of Cape Town, and he'll present on the topic of manufacturing tiles from copper mine tailings using geopolymerization. Karabo completed his Bachelor's of Science in Civil Engineering at UCT in 2022. He's currently working towards his Master's in Civil Engineering at UCT. He is an advocate of driving change through circular and sustainable resource economies through engineering and entrepreneurship. In his spare time, he enjoys unwinding outdoors, particularly hiking the trails of Table Mountain and swimming. So again, one of our nature lovers. Karabo, I'm going to hand over to you.
Thank you very much, Lisa. Good morning, and thank you all for giving me this fantastic opportunity to share my research. On the next slide is the outline of my presentation. I will begin by presenting the problem, then discussing a sustainable solution. I'll describe the methods I used and present my findings. I'll conclude by considering the economic viability of my proposal. This next slide breaks down the problem. When one thinks of a mine, what typically comes to mind is a hole in the ground next to a heap of unused rubble. The image on the left shows one such heap, referred to as mine tailings. This is the unwanted byproduct of mineral extraction comprising fine-grained dust and processing fluid. Globally, 100 billion tons are generated every year, which is enough to fill up 14 million Olympic-sized pools. Current best practice is to store these tailings in expensive storage facilities. However, these present problems even when managed well. On the left-hand side of the next slide, the environmental cost is shown. Rain reacts with the tailings, leading to acidic water draining into waterways and poisoning plants, animals, and crops hundreds of kilometers away. To the right is an indication of the health problems, with wind blowing the fine particles into people's lungs, leading to fatal respiratory problems. On the next slide is an example of the catastrophic failure that regularly occurs. In 2019 in Brazil, 259 people died due to a tailings storage facility failure. The current solution is unsustainable due to the fact that these facilities need to be managed forever, and management does not eliminate risk. As shown on the next slide, the status quo is unacceptable. So my aim with this work is to convert problematic material into valuable products, thus providing a solution that meets the sustainability triple bottom line. The chemical process I use to do this is laid out on the next slide. Geopolymerization leverages the unique chemical properties of mine tailings, adding an alkali solution of high pH and curing at slightly elevated temperatures triggers a reaction that bonds the loose tailings material into a solid stronger than cement. The next slide overviews how I used this process to meet the objective. I'll begin with how I made the geotiles, the design chart I developed to meet the criteria, and then the testing methods that I employed. The manufacturing process is shown on the next slide and comprises 3 broad steps: mixing the tailings with a solution of sodium hydroxide, shaping the mixture with a hydraulic press, and then curing the tile in an oven. The next slide shows the apparatus I used for the second step. This vibrating compaction mold shapes the tile and is what goes into the hydraulic press. On the next slide is the design chart I used to ensure that the tiles meet standard specifications. Everything to the right of the green dashed line meets the American standards for breaking strength, whilst everything above the red dashed line meets South African specifications for a calculated value called the modulus of rupture. The next slide shows the blue lines that predict the, previous slide. Yes, the blue lines which predict the theoretical performance of tiles based on their thickness. This value is given in millimeters. Now, different tiles made will fall on this plot, and to achieve technical feasibility, we want a tile that falls in the green region at the top right of the plot, as that indicates the condition where both standards are met. To plot tile performance on this chart, the next slide shows the tests I employed. The technical feasibility was measured by the breaking strength test, water absorption, and abrasion resistance tests, which I'll describe in a bit more detail in the next slides. Breaking strength is straightforward. You press down on the tile and measure the force to break it. This gives the breaking strength, and using a formula, you can calculate the modulus of rupture. The next test is shown on the next slide, and this is the water absorption. Here, tiles are boiled for 2 hours. They suck up water and become heavier, and this change in mass is recorded. In the picture, the tiles are placed between some circular concrete discs in a water bath. And finally, the next slide shows the abrasion test. Sand goes into the white funnel at the top of the picture in the middle, and then pressurized air blasts the sand onto the tile at the bottom that's placed beneath the nozzle. Results from this test show on the right that curing the tiles in the oven for the 1 and 2 days did not meet the specifications, and that's why there's holes in those first 2 tiles. However, 3 days curing provided sufficient strength. And in the next slides, I'll present the results of the previous 2 tests. Right. Next slide, please. I first found out how long the tiles needed to cure for. Immediately, we see that none of these tiles fell in the target region. The square tile cured for 1 day met neither specifications, whereas the 3, 5, and 7 day tiles beat the green American target line, but fell below the red South African target line. The triangular 3 day tile we see, however, is closest to the green target region in the top right. On the next slide shows what happened when I varied the tile thickness. We can see that neither of these 2 thicknesses fell in the green target region. However, on the next slide, we see what happens when I increased the solution concentration. We can see that here, increasing the concentration gave us a tile that was in the target region where both American and South African specifications were met, although narrowly. I'm currently investigating other variables to produce geotiles that fall more comfortably within the target region for my master's research. Nonetheless, the results show that technical feasibility has been met. So far, so good. But the real question is if we can make money from these things, which I'll address in the next slide. To answer this, I developed an economic model to compare geotile profitability to that of conventional tiles. The primary material comprising a geotile is the mine tailings, which I've assumed to be free for this analysis. And this is conservative because mines would be happy to have someone take the tailings off their hands. The costs I did consider are shown on the next slide. The production costs include the alkali activator, the electricity for curing the tiles, and the products used to give them the aesthetic finish. And on the next slide, we can see the results. Total geotile production cost in orange were then compared to retail prices in blue for some standard sizes, which are shown on the x-axis. I got the sizes and the retail prices from CTM's online catalog, a local tile retailer, and the peach bar shows the potential profit. As can be seen, geotile production can be economically feasible for a range of commercial tiles. To highlight the sustainability of my solution, the triple bottom line model was used on the next slide. At the top, we have economic sustainability. Geotiles can be sold for profit whilst simultaneously dropping mining operational costs, resulting in buildings with improved green ratings. On the left, the social benefits are indicated, the main one being the health benefits associated with eliminating large volume wastes. Secondly, geotile production is less capital intensive than that of conventional tiles, as all you really need is an oven. And this ease facilitates entrepreneurship. On the environmental front, geotiles production uses significantly less heat than conventional tiles, resulting in less embodied carbon. Lastly, reducing the prevalence of tailings waste will result in clean air and water. So to conclude on the next slide, I found that the unique chemical makeup of mine tailings can be leveraged to make an environmentally sustainable and profitable product, which addresses problems that contemporary mining problems bring to the fore. The manufacture of this product benefits society with respect to improved health and economic outcomes, and also opens doors for low-skilled individuals without access to significant capital to engage in entrepreneurship. And yeah, finally, on the next slide, I will thank you all for listening. And as mentioned at the beginning, please don't hesitate to ask questions in the chat. Thank you very much.
Thanks, Karabo. That was so fascinating, and getting rid of, what do they say? One man's trash is another man's treasure. It's a great example of that. Thanks so much. So please put any questions you have in the chat box. And we will be moving on to the property category. So in third place, we have Barrett de Villiers from the University of Cape Town on investigating the adoption of green building features, initiatives, and technology in commercial buildings. Barrett completed his honours in quantity surveying at UCT in 2021. He's now working for CE Quantity in Cape Town. He also thoroughly enjoys the outdoors and primarily surfing and trail running, hence his devotion to look after the environment and all that live in it. He aspires to become a green building and sustainability expert and advocate, especially within the built environment. So he's definitely in the right space. And as you saw, one of the prizes is an accredited professional course, so which all the winners will take us up on. So Barrett, over to you.
Thank you very much, Lisa, for the introduction, and I would just like to further extend my thanks to the GBCSA as well as Growthpoint for the opportunity to be here with you guys today. Anya, if you can move to the next slide, please. All right. So the year is 2050, and climate neutral urban living has never been better. All new and existing buildings are net zero across their entire life cycle. The world's cities and towns are healthy and sustainable places to live. The world has worked together to exceed the goals set by the Paris Agreement, with global temperatures only rising 1 degree Celsius in the past 3 decades. The Earth and all that live on it are thriving. Next slide, please, Anya. Back to reality. The year is 2022, and global temperatures are set to rise by at least 2.7 degrees Celsius before the end of this century, leading to catastrophic changes in global climate and life on Earth. Literature indicates that the global construction industry and its products is responsible for 16% of global water consumption, 30% of global greenhouse gas emissions, and a whopping 40% of global energy consumption. Next slide, please. These are rather alarming figures, but there is no need to fear when Antonio Guterres is near. In order to essentially save our world, COP26 calls for drastic measures to reduce emissions. The United Nations Framework Convention on Climate Change has set the goal for all new buildings to be net zero carbon in operation by 2030, and all new and existing buildings to be net zero carbon across their entire life cycles by 2050. This is where we pull back the curtains and say, enter green buildings, an estimated $24 trillion investment by the year 2030. Thanks, Anya. Next slide. Green buildings are considered to be the primary solution to achieve climate neutrality in the built environment. Not only are they absolutely stunning to look at, but literature indicates that typical green buildings produce 34% less greenhouse gas emissions, consume 40% less energy, and 11% less water than conventionally constructed and operated buildings. Next slide, thanks, Anya. Like all good things in life, green buildings come at a cost and not without a few complications. Literature indicates that the main factor that hinders the widespread adoption of green buildings is the perceived higher initial cost associated with its adoption. Other relevant complications include the lack of awareness around the benefits of green buildings and the lack of green building knowledge. Next slide, please. This is where my research comes into play. The rationale for this research stems from the urgent need for a more climate-neutral built environment, as well as previous research stating that developers and investors find it difficult to justify the higher initial cost associated with adopting green building features. With this being said, my research attempted to drastically improve the grounds on which green buildings can be easily justified. Next slide, please. So without any further ado, let's take a closer look at the findings of this research. The data collected is described with reference to 6 important key factors. The most popular responses under each key factor is accompanied by a lightning bolt. Okay, so first up, we have the advantages of implementing green building features, with the most popular advantage being found that the implementation of green building features significantly reduces energy and water consumption, which are both very limited resources in South Africa. This is followed by occupant well-being, raising awareness about sustainability, increased occupant productivity, green leasing options, and promoting participation in sustainable practices among building occupants. Next slide, please. Then we move on to the different types of green building features that have been adopted in commercial buildings. The most popular green building feature was found to be solar PV systems and smart LED lighting. These are followed by sustainably sourced timber, natural ventilation, eco-bricks, natural daylight optimization, rainwater harvesting, desalination plants, grey water treatment, seawater cooling, engineered facades, and water-wise sanitary fittings. When we look at solar PV plants as a green building feature, it was evident that economies of scale were achievable. In one case study with a relatively small solar PV plant, the interviewee reported that they are looking at a 20-year payback period on their investment, with their plant only being able to supplement around 10% of the annual energy consumption. Another case study boasts with one of the largest solar PV plants in a commercial building within South Africa. The interviewee from this case study reported a mere 4-year payback period on their investment, with their plant supplementing their annual energy consumption by up to 65%. Thanks, Anya. Next slide. So onto the barriers that hinder the adoption of green building features. The most dominant barrier to the adoption is the perceived higher initial cost of constructing a green building, as well as the issue of split incentive, where a building owner sells the building straight after construction and is not able to reap the many long-term benefits of owning a green building. This is followed by barriers such as a lack of green building knowledge, lack of experience in the industry, and a building's physical inability to accommodate green building features. Next slide, please, Anya. And now we have arrived at the ever-important potential to reduce costs. The chart that is currently displayed on the screen illustrates the actual reduction in operating cost per square meter of gross lettable area as different green building features are implemented. So each bar represents a stage of green building feature implementation, with the details of the specific stage presented in the legend below. Each green bar represents how operating cost per square meter gradually decreases over each respective stage. The monetary value of operating cost can be found at the bottom of each green bar. When we look at each orange hatched bar, it represents the cumulative percentage decrease in operating cost from stage 1. So when we look at it holistically, in essence, the figure shows that the implementation of green building features has the potential to reduce a building's operating cost per square meter of gross lettable area by almost 60%. Next slide, please. So Although I would thoroughly enjoy speaking with you for the entire day, we have reached the home stretch of this presentation. And as I previously mentioned, the aim of this research was to build better grounds for green buildings to be seen as an easily justifiable investment. And based on the findings that we have just discussed, there are three main concluding remarks I want to draw your attention to. First up, it is quite evident that the benefits of green building features heavily outweigh any of the drawbacks, and that these benefits are not only environmental in nature, but also extend to the social and economic spheres of sustainability. Social benefits include, but are certainly not limited to, increased occupant well-being and participation in sustainable practices. Economic benefits include, but are not limited to, significant savings in operating costs, higher rental rates, and higher property value. Next up, it is evident that the implementation of green building features has a significant potential to reduce the operating cost of green buildings by up to 60%, a very enticing figure given the ever increasing price of electricity in South Africa. When taking all the key findings into consideration, it can with the utmost confidence be concluded that the adoption of green buildings and the features that go with them pose as a one-stop shop for solution to many of our sustainability issues faced in the built environment and across the globe. Next slide, please, Anya. So from my side, this is goodbye for now, and I would like to thank you all for your time and for the opportunity to share some of my passion with you today. Remember, the future is green, so let's start coloring. Thank you very much.
Thank you, Barrett. I like that tagline. Very, very cool. And just so you know, we do studies regularly, and we've shown that the cost of green is not as high as people think it to be. So it's a nice sort of connection. So let's look at the second place winners on the property category. It's a team. It's Asif Mohammed, Asimashle Nkuma, and Sasha Harper. They will present, on experimental process of introducing chicken manure as an additive in Portland cement to decrease pollution and increase thermal insulation, as well as other properties of concrete mix. So I'm not even going to ask them how they came up with this idea. Asif completed his honours in quantity surveying at the University of Witwatersrand in 2021. He's an aspiring quantity surveyor with a passion for architectural design and construction. He's currently employed as a junior QS at AMPM Projects, Pty Limited, and aims to develop his career through continuous learning and professional exposure. And he says Adrenaline Junkie is his middle name. Ashimashle completed her honours in construction management at WITS in 2021. She's now working as a teacher's assistant at the university and is furthering her studies in MSc engineering and civil engineering. She loves listening to faith-based music and podcasts. In her spare time, she enjoys eating out with friends and touching base with her family over social media. Sasha completed her honours in quantity surveying at University of Witwatersrand as well in 2022. She's currently the junior quantity surveyor for projects and industrial engineering since 2021. She loves going to the gym and creating art. Her other side hustle and hobbies include being a hairstylist. So a nice eclectic mix of a team. I will hand over to you, Amrata, to you three, to present your project and your findings.
Good morning to my fellow panelists, as well as the attendees of this webinar. Next slide, please. The inaccurate management of chicken manure is a global issue, whilst toxic waste in the form of carbon dioxide from cement is released into the environment annually. We saw that a more improved strategy for managing chicken manure as well as cement production is needed. Our research sought to reduce costs and carbon dioxide emissions by substituting cement with chicken biomass and other recyclables such as pulverized fly ash, and ground granulated blast furnace slag. Next slide, please. The question is, how can we use these ingredients to produce a cheaper and more environmentally friendly concrete mortar? In this next slide, we will outline our objectives of our research, which are to determine the rates of increase in cement and concrete prices in South Africa, analyze the environmental effect of cement production using literature, explore the application of biodegradable biomass as a concrete additive, and calculate if chicken manure can be put in concrete to make it more sustainable. In the next slide, we'll outline the materials that we used for our research experiment, which are GGBS, PFA, chicken biomass, which included seed-based chickens, water, and activators, which were acid-based. In the next slide, it will detail our design mix for the various mixes we did in our experiments. I will now hand over to my colleague to talk about our methodology and protocols in the next slide.
Thank you, Sasha. Next slide, please. So our methodology and protocols, it is essential to follow the protocols if someone would like to attempt to do this experiment in future. What we did first was we dehydrated all the materials, as you know, because moisture carries weight and we need to obtain accurate results, or most accurate results as we can. So the ground granulated blast furnace slag, pulverized fly ash, and chicken manure were placed in a general mixer, a blender. We created 6 samples, all had different plastic bowls, and ingredients were measured and placed in each. According to the previous slide with the design mix, each design mix had different ratios. It is essential that when the ingredients are combined with water, it is incorporated and mixed well to reduce any lumps in the mixture. We used isoprisms, which was 0.24 cubic meters in volume. They were sprayed with spray and cook and filled with a mix. We also, the molds were filled and placed in a vibrating table in order to minimize any bubbles that formed in the mixing process. Plastic wrap was placed on top of the molds to be cured so that the concrete can cure in its own moisture, and it also, so therefore it was used to trap the moisture in. Once it was cured, once it was curing, we placed it in a temperature controlled bath at 24 degrees. The air in the room was also temperature controlled at 24 degrees. Next slide, please. So from there, we did crash tests on day 3 and 7 of our experiment. So we did compressive and flexural strength tests on our experiments at day 3 and day 7. Next slide, please. So this is a graph comparing our results. So the compressive strengths that we achieved during the day 3 and day 7 of crashing, mixes A, D, and E achieved the best results, as then B, C, and F, which achieved 0 results. Mix A achieved close to 45 MPa in concrete strength. Mix D achieved close to 35 MPa, and mix E achieved close to 10 MPa in concrete strength. Next slide, please. Next slide, please. Our cost per 0.24 cubic meters. So we use the normal concrete, the current rate that is being sold at 0.24 cubes of concrete, and we use that result to calculate the temperature, the price difference for our samples, and looking at it at an average of 80% cheaper than normal concrete. Next slide, please. So these are just the cost differences in percentages that were achieved for each sample mix. As you can see, A was the strongest performing sample at achieving 92% cheaper than normal concrete. Mix D at 90% and mix E at 88%. Next slide, please. I would like to hand over to my colleague.
All right. In conclusion, we found that chicken manure can be used as an additive in concrete mortars. We also found out it performs better when mixed with PFA and GGBS. However, though, we could not determine whether it performs better over time. So that means we would have to do the experiment for a longer period of time. We only managed to do it for 7 days because we didn't have that much time. In terms of the cost comparison, we were able to do a cost comparison of the different mixes, even though it was challenging to measure it in rands. This study found that biodegradable biomass-infused concretes can be environmentally friendly and cheaper. Next slide, please. So for our contributions, our research is an alternative approach to existing waste management strategies, and it aims to help various stakeholders to, number one, reduce waste byproducts from reaching landfills, freshwater dams and rivers. Number two, to be an investment opportunity to upskill the education sector in terms of trade skill development for those who cannot afford higher education. And lastly, it aims to create new job opportunities that could ease our very high unemployment rate. Next slide, please. And then for our recommendations, we have made the following suggestions. So mix A at 45 MPa is our strongest performing sample. Therefore, it can be utilized in commercial and civil building works for structural columns and beams. And then mix D at 35.5 MPa can be used in housing projects, which can help alleviate the housing backlog in the country, as well as assist the government in creating environmentally sustainable and affordable housing. And then mix E at 10 MPa can be used for non-structural works and for paving blocks as well. And then finally, we recommend that mixing chicken manure with GGBS and PFA should be the way to go because it increases the strength of a concrete mortar and is also environmentally friendly and sustainable. Next slide, please. And then in terms of industry alignment, our research aligns with the Paris Agreement, which spoke on reducing greenhouse gas emissions that cause global warming. And it also aligns with COP26, which requires countries to limit their temperature increases well below 2 degrees and reduce coal usage so to inhibit climate change from carbon dioxide emissions. Lastly, our research also falls under the Sustainable Development Goals to transform the world, which are goal number 12, responsible consumption and production, as well as goal number 13, climate action. Thank you so much for your time. And lastly, I'd just like to ask you this very important question of what are you going to do about it? Thank you.
Thank you very much. That is a very important question. There's a saying like, if not now, when? And if not you, who? So, great question. Cool. We are on to the first place winner of the property side, and it's Tristan Fernandez, and he will give us enlighten us on a life cycle cost analysis of developing high-rise, sustainable, innovative, affordable housing in South Africa. And as I said, he's a winner of the property category. Tristan completed his honours in property studies at UCT in 2021. He's currently completing a 6-month internship at Equitas Property Fund in Cape Town. He's confident, accomplished, and highly motivated property professional, skilled in forecasting cash flow statements and identifying new market opportunities. He's eager to utilize and apply the knowledge he's acquired during his year of studying in a way that can benefit real-world problems through PropTech and smart buildings. And yeah, affordable housing, definitely a real South African problem. So, Tristan, on that note, I'm handing over to you.
Thank you, Lisa. And good morning, GBCSA, property and sustainability professionals. Next slide, please, Anya. As an introduction, affordable housing is a market not really tapped into by developers and investors. This is often due to the perceived high risk apparent within this market. However, owing to the size of the demand, the large potential for return is undeniable. Studies estimate that there are approximately 4 million South Africans earning between 3,500 and 7,500 Rand per month. The problem comes in with the fact that these households fall out of government housing subsidy requirements, but also earn too little to qualify for a sufficient mortgage bond. As a result, there is minimal affordable housing stock available to this low to middle income bracket. Next slide, please. However, before getting into the gist of the presentation, I think it's important to take a moment to provide some insight into the affordable housing backdrop in South Africa. Currently, there are several housing programs in circulation, with government having attributed a considerable amount of resources towards the supply of housing, as well as the successful delivery of 3.5 million homes in South Africa to date. Yet, the economy remains fighting an ever-increasing and prevalent issues relating to an affordable housing crisis, with a backlog of an estimated 2.3 million, approximately 12.7% of South Africans still living within informal dwellings, and a growing gap market. These issues are due to fundamental problems existing within South Africa's housing delivery framework, which relates to factors such as poor quality, inaccessible locations, and general unaffordability, ultimately resulting in current housing programs continuously failing to meet user demands, needs, and expectation requirements. In addition to this housing crisis, several other factors are plaguing the CBDs of major South African cities, such as increasing vacancy rates, urbanization, and the lack of well-located land. Based on these factors, a potential solution for this sector that mitigates these identified problems is in high demand. Using this as a foundation, I set out to conduct a full life cycle cost analysis to assess the overall feasibility of two affordable housing designs: the conventional low-rise design currently being implemented across South Africa, and a new sustainable, innovative, and affordable design in that of inner city high-rise affordable housing. Next slide, please. The results of the research reflected the following findings. Firstly, that different affordable housing designs have a notable impact on the specific components of a building. This is a result of the cost discrepancies that arise between the alternative housing designs. In this regard, it can be seen that the cost items of construction and operating costs illustrate that the high-rise design reflects net increases in the total life cycle costs. However, in contrast to this, the cost items of acquisition, maintenance, and social costs illustrate that the high-rise design reflects net decreases. Next slide, please. On this slide, the different percentage contributions pertaining to the different cost items are highlighted, emphasizing that in both affordable housing designs, it is the social cost that represents the largest contribution to household expenditure, illustrated by the 85% and 65% for the low-rise and high-rise design respectively. Next slide, please. Here, these pie charts show the cost savings a household can achieve for the respective cost items across the different housing designs. The cost items of construction and operating costs increase household expenditure, represented by the -11% and -13%. However, the cost items of acquisition, maintenance, and social costs show decreases in household spending, shown by the 9%, 72%, and 70% cost savings, ultimately resulting in a total cost saving of 61% per household over the entirety of the building's lifespan. Next slide, please. To summarize, what is most important to note from this research is that the cost items of construction, acquisition, and operating costs are within a relatively similar brackets of each other, plus or minus 10% across both designs. However, it is the cost item of social costs that results in being the main contributor to overall household costs, showing that the common conception that construction costs are the costliest item to a household as false, and that when adopting a life cycle cost perspective, it is in fact the social cost, which relates to traveling and value of time expenses, that impacts a household most significantly. Additionally, the significant difference in the life cycle cost of this particular cost item between the low-rise and high-rise design illustrates that both these elements are heavily influenced by location. Therefore, as a direct result of increased accessibility in that of inner-city high-rise, sustainable, innovative, affordable housing, household costs are significantly reduced. Next slide, please. In concluding, often housing affordability is solely looked at through the lens of current construction costs. On this basis, affordable housing is seen as a risky and unfeasible asset class for both the public and private sectors. However, through adopting a value-based approach, one is capable of looking at housing from a life cycle cost perspective that encompasses more than just the physical building. In this way, uncovering that significant cost savings can be achieved, general affordability of household positively influenced, and overall household wealth increased, purely through better located, sustainable, innovative, and affordable high-rise housing, as well as deriving additional benefits, such as significant reductions in CO2 emissions, increased safety and security for households, better social cohesion and use of shared infrastructure, and ease of achieving Green Star ratings. In this light, households no longer face a trade-off between housing and location, therefore making affordable housing a feasible investment in all aspects, and allowing government, developers, and investors to tap into this market through leveraging this increased affordability. Thank you.
Thank you, Tristan. Very, very interesting. I would also like to point you to, we did a project last year with diversity, and it was around sort of carbon saving of people living closer to where they work and where they study. And it really, really is much smaller carbon footprint. So, and that would add to what you've already concluded. So, can I ask our panelists to come back so that we can perhaps ask some questions that have come up? Thanks, Asif. Waiting for everybody. Sasha, Barrett. Oh, are we all here? Perfect. I have a question for Barrett from the audience. Barrett, why is hydroponics and aquaponics not included in your possible solutions which can further reduce emissions? What are your thoughts on that?
Yeah, just to generally answer that question, I would have loved to explore all the possible solutions, but unfortunately for honours research, you have pretty much a very limited time. I wouldn't say resources, but very limited time available, and you need to kind of confine your scope to a more specific or certain direction. So definitely at the start of my research, I would have loved to implement or to explore all those avenues, and I definitely think both those can pose as good solutions. But unfortunately for this research, I could not find the time to implement it. But not writing it off at all, I think it is are both very good solutions to the problem.
As you say, I think there's huge possibilities in all your subjects, all of you. But yeah, time is always the limiting factor. A question to Karabo. Karabo, you've said that the tailings are dangerous as raw materials. Does this danger get eliminated once they are put into the tiles?
Thank you very much for that question, Lisa. Yeah, so the tailings are generally dangerous in two main ways. The first is that they're fine, and the second is the heavy metals that they contain. So the fineness is dealt with just due to the geopolymerization process sticking the particles together, but it's the heavy metals that are a little bit trickier. Now, the theory predicts that the heavy metals get captured both chemically and physically. And to test this, a geopolymerized brick was made and dipped in acid, and then it was broken in half and then dipped in acid again. So if the presence of the heavy metals, if the heavy metals were not neutralized by the process, the acid would have contained traces of the heavy metals. But because in neither of the cases heavy metals did not leach out, sorry, in neither of the cases there were no heavy metals found in the acid, it was concluded that the theory was correct, that in fact the heavy metals do get neutralized.
Thanks for that. We have a comment from Len Victor. He just said, extremely interesting topics today. Enjoyed it. Congratulations to all the winners. You are a great asset to our industry. So I thought I would just share that with all of you. Just watching the question box here as well. Okay, I have a question for Tristan. It says, the data you present is very interesting. However, I'd like to know whether you have any recommendations on knocking down some of the barriers to entry for developers and investors to enter into this market. Do you have any comments on that?
Yes, so just want to make sure I am. Thank you for the question. So I think government can get involved through possibly implementing tax and rates and taxes reduction policies. This will hopefully allow the developers to reduce their operating costs and still achieve the required yields and profits that they need to undertake the development. Another possible avenue, and I didn't specifically look at this in my research based on time limitations, but I'd possibly like to explore it in the future, is to retrofit existing office stock, especially with the high vacancy rates. Just from some of the general research I have done or reading I've done at the moment, I see that one of the problems is that the rate per square meter of the office space needs to be reduced quite significantly from about 20,000 Rand per square meter to around 8,000 Rand to stay feasible for investors and developers. And yeah, again, I think is another possibility for government to get involved and introduce subsidies that aim to bridge the gap between the 20,000 Rand to the 8,000 Rand.
Thank you for that. Just Nina, I'm going to put you on the spot because this wasn't. It's one of my questions. Is the big thing about the sort of plastic recycling is collection. Have you looked at the sort of collection of waste? And I must tell you, one of the things I do like is one of the problems that we have with plastic waste is the separation of waste, and I think your proposal actually takes that problem away. But it's still getting, one of the things we don't want to do is put voyage miles on plastic to get to these construction places. Have you sort of looked at the concept of the actual collection of the waste?
Well, the nice thing about Resin 8 is that it incorporates all the plastic waste. It also incorporates metals, papers. So anything that is found in the dump is pretty much taken, cleaned, shredded up, and that's how we got that material of Resin 8. Peat is a bit more complicated. As you said, there is a sorting process having to be done because everything's mixed together. I actually sourced peat from a recycling company. Pretty much what they do is they go to the landfills, get all their plastic, and they manually sort it using machinery and themselves. And then there's a bit of a process. You got to clean the plastic, you reheat it up, Then it goes into pellets, and then from this form it gets crushed up and then put into your concrete. Yeah.
Instead of pressing unmute, I press my camera. It's like, you know, occupational hazard in these days. Thank you for that. Andrea, what I wanted to ask you is, you looked at obviously industrial LED fixture solutions. What makes that that solution better than other alternatives? Because I think you did touch on that there are other sort of lighting alternatives. So what led you to this LED fixture solution?
So if you look at the alternatives, what are the alternatives? So firstly, one alternative may be a solar solution. So you implement a solar solution in your factory and drive all your lights from solar panels, but that defeats the purpose of energy saving. So solar, by using solar, you actually just replace the source of the electricity and not actually saving on electricity costs and electricity usage. So yeah, that's one benefit. Another is the solution that I implemented also offers significant scalability. So it's easy to take out a node and expand on the number of nodes you want to implement. Generally, other options also use wiring or just cabling, requires cabling. The option that I researched was using a wireless means of communication. So you eliminate all the needs for cabling and wiring, which adds to the cost. And yes.
Great, thanks. I mean, I must tell you as well, we in the Green Building Council, the big push is first energy efficiency, then energy generation from renewables. So that is definitely the like, yeah, the sort of, well, how we believe the right aspects. Just conscious of time, and now the questions are coming in thick and fast. And I see Sasha's not here, but I have to ask, what led you to chicken manure? Please, it's driving me crazy.
So at first we decided to move with an experiment for our thesis. So we sat down and we broke down as to what possible niche experiments that we could come up with. And we made a list of crazy ideas, and chicken manure happened to be one of them, as well as plastic in bricks and etc., etc. So at first we weren't planning on creating a cementless concrete base. We were looking to substitute some parts of cement with chicken manure. But then we approached a scientist from Eskom, and he was telling us that, you know what, there's billions and billions of waste from Eskom that can be used in concrete. Why don't you try it out? So then we changed our whole focus of our thesis, and we ended up mixing everything together and hoping for the best. It was a shot in the dark. And then when we did research a few topics, and a few of them came up with cattle manure was used in concrete, but it wasn't effective, so there wasn't much detail about it. So we were just like, you know what, we just went for it. There was no idea. We were just going with the flow. We were just winging it, faking it until we make it, basically. Yeah.
That's great. I like that approach. There's it's a comment. And Andrea, would you be able to collaborate with a non-profit organization to include the Sun Exchange Solar System program to include your systems internally? From Anthony from Rain, I think it is. It's really a question if you would be able to collaborate with a non-profit organization on your solutions.
Yes, Anthony, I'd be happy to do that. You can, I think on one of my slides, I've left my email address, so you can contact me I'd be happy to do that.
Oh, that's great. Nice little networking here as well, which is always a bonus. So it's perfect. This is to all of you. It's from Manfred. He says, well done to all the participants. Great set of projects. Do any of the contestants have suggestions on how we can improve the Greenovate, having come through the process? So be nice, guys, but what can be done better in the future, or what were your experiences? I'll leave it open. Anybody with any comments?
I might have a quick comment there, Lisa.
Yeah, please, Barrett.
I think at the start of the honours year, when you choose topics for research, I think some people might not always have the best idea of exactly what they want to do, or what the current problems might be in the real world. So I think if the GBCSA can maybe produce a couple of topics based on what they're experiencing in industry and experiencing at the moment, that might be trouble areas or problems or an area where a solution is needed, that those topics get directed to those areas, and then students might have the opportunity to choose from those and to address actual issues going on in industry.
No, that's a good point, and good comment. Any other comments from anybody? Because I mean, we like to think we're perfect, and it's all good if you agree with us. I have another question. Sorry, it's to Tristan. Have you looked at any of the studies on social outcomes of people living in high-rise buildings in other parts of the world? And congratulations to contestants, thought-provoking, and the congratulations set from Mike Heathcote. So it's, yeah, so Tristan, have you looked at any of the studies on social outcomes of people living in high-rise buildings throughout the world?
So thank you for the question, Mike. So yeah, as general reading, when you're doing your literature review, I was looking, I think, countries like Malaysia, Singapore, a lot of them have adopted this high-rise affordable housing strategy, and it seems to be working quite well. Like I said, there's lots of savings that can be achieved through shared infrastructure. Obviously, in the South African context, it is a little bit different because of our apartheid history and the town planning that kind of happened around there, where Black populations were pushed to the outskirts of the cities. So there's quite a lot of management that has to happen with traffic, and there's a lot of differences from a South African context compared to these other countries. But I did do some reading, and I think as part of government implementing sort of strategies going forward, I think a lot can be taken from these countries. Yeah.
No, absolutely, that's great. Then I'm conscious of the times now, and the other questions are coming thick and fast, which is great, but I know time's ticking on. From Mike as well. Hi, Asif and the team. Is chicken manure not used as cattle feed? It's got a high energy value. I don't know if you know the answer.
Chicken manure compared to cattle manure, well, the chicken manure is way more acidic than cattle manure because of the seed-based diet that they follow, majority of the chickens. So when it comes to distinguishing between the two, the high acidity in chicken manure actually helps to cure the concrete better. And Sasha, would you have anything else to say to that question?
Yes, to add on to
Sasha,
what
you jump in.
Thank you. Chicken manure is used as cattle feed in some countries, like in Europe, but it is a bit of a controversial topic, and it has actually been stopped. I read somewhere that since 2001, there was like a case going on because it can only be done like sparingly. Only a small amount of it can be given to cows as feed. So as much as, you know, it can be used in that regard, there's still a lot of it that is still being dumped and is not properly, you know, yes.
Thanks, Sasha. Yeah, I always get concerned about making herbivores carnivores by feeding them strange stuff, but all good. As I say, the time is marching on. I would just like to, I don't know if we got the slide, Anya, remind everybody that from the 2nd to the 4th of November, we have our Green Building Council convention at Century City. You will see the Greenovate winners on this the stage, I think, and doing their presentations. So we like to really showcase them. They will be there. So if you want to come have a chat and you know, network, get these innovative minds while they're nice and fresh and got all these great ideas, please join us. Graham, I don't know if you want to pop on your slide. Once again, I just want to say thank you to Growthpoint in this partnership. We always love it. And I don't know if you want to say anything for a quick minute, Graham.
No, I think I said my piece at the beginning of the session, so very happy with that, and refreshing to run through the presentations once again. Yeah, so congratulations to all the finalists. And yeah, I think nothing else to add. Thanks, Lisa.
Yeah, thanks, Graham, and thank you again to all the panelists. As I say, it's really one of my great privileges to do this presentation. I'm looking forward to seeing you in our circles going in the future. And you know, when you're rich and famous, remember this is where you started. So be with us. And on that note, I just want to say congratulations to you all, and thank you for your time. Thank you for your foresight, and thank you for being part of this great program. So on that note, I will say goodbye to everybody, unless I haven't done any more housekeeping. Anya, you must just remind me, but if not, thanks guys, and have a great day. Stay warm to all of these who are freezing in Gauteng and in the Western Cape. So thanks guys.